Hello, my name is Claire Smith, and I'll be presenting on behalf of the Verizon Connect MEID team for Capstone Spring 2021. So a little bit of background on this project. We are designing an asset location tracker for Verizon Connect to be utilized by trade contractors for logistical coordination and management in the construction industry. So to your far left, you'll see a job box, which is used by trade contractors to store smaller assets. In the middle, you see a trade contractor doing what they do best, which is their specialty work, in this case, electrician. And then lastly, you see a scissor lift, which is an example of one of the assets we've been focusing on. So speaking of these assets, we decided to categorize them into 4 different tiers. At the top, we have the most expensive and largest assets. So in this case, you see a mobile building used as a job site home. And these are assets worth greater than $10,000 typically. Our medium tier is what we decided to focus on for this project, and these are assets that are $5,000 to $10,000 that either are a job box or do not fit into a job box. And then we have our small tier, which is $200 to $5,000 assets, and these do fit into a job box or are larger but don't really have as much value. And then lastly, we have our micro tier, which is smaller tools such as hammers, inexpensive drills, and other hand tools, and these are easily broken or replaced. So we decided to coordinate our different asset tiers to different players in the system that we conceptualized. So first of all, we have Verizon Connect's existing asset tracker, which we decided to call the home tracker for the sake of this system. And this tracker is used currently to track top tier, so the greater than $10,000 assets. And it has GPS, LTE, Bluetooth, and a 6 to 8 year lifespan. Next, we have the witness tracker, which is what we ended up focusing on for this project, which focuses on medium tier assets and has GPS, LTE, Bluetooth, RFID scanning, and a 1 to 2 year lifespan. Next, you have the active tracker, which is for small tier equipment and only has Bluetooth and a small battery. And then lastly, we have passive trackers, which are for micro tier assets and consist solely of a passive RFID tag. So here's a visualization of this network. You can see in red the Bluetooth radius of the witness trackers. And you can see in the yellow circles, these are the active trackers. So these are small Bluetooth trackers. And the way that this works is the Bluetooth trackers, these active trackers, communicate one way to the home or witness trackers, which then communicate with each other via Bluetooth or via LTE, and transmit that data to then the trade contractor's iPad or phone, where they can then use that logistics data to improve their function. For example, if they realize that they have no more hammers left on site because they've all gone missing and nobody has checked them in at the end of the day, then they know that they'll need to go buy more hammers and they can then be more productive the next day instead of having to spend that time searching for those assets. And here's an example of what that interface would look like. So you can see the map overview, the different trackers that they might have on site. They might have multiple witness trackers or multiple home trackers. And then for each witness or home tracker, they can see the assets associated with those. So for example, all of the jackhammers you see, it shows whether or not they are checked in or out of a job box. So again, we focused on the witness tracker, which has GPS, LTE, Bluetooth, RFID scanning, and a 1 to 2 year lifespan. So we did a few different evaluations for this tracker. We looked mainly at power evaluation so that we knew we'd be able to achieve that 1 to 2 year lifespan. And we looked at this in an active mode that we based off of the existing tracker from Verizon Connect's PCB that was included and we got to play around with. And in an active mode for that, and including the RFID scanning that we want to add into this PCB, we're looking at a power capacity that indicates a lifespan of 1 to 2 years, which is exactly what we were looking for. Next, we also did an experiment to confirm that Bluetooth would be a valid mode of connectivity for this project. So we did an experiment using a tile tracker and a phone Bluetooth scanner app. And we also used this formula for looking at signal strength. And our findings essentially matched what Tile's specifications are on their website. So we think that our Bluetooth would cover about 3,000 optimal square feet, which is much larger than the average home, which is great for smaller contractors. They would be able to use this tracker for an entire job site. So here are some final design specs. You can see this size compared to a credit card. And these are the components. It has a battery door, which allows for battery replacement, and then a few other essential things, including gaskets. And we've reached an IP67 waterproof rating, which means it's waterproof up to 1 meter. We also conducted an FEA analysis, and it did not reach the yield strength, so all good there. And lastly, we attached it to assets in a variety of ways using this attachment mechanism. We use screws, adhesive, and ties. So for screws, we have 4 sheet metal screws, and the tracker just snaps into this, and then the front case is secured over it, preventing the tracker from being removed. Adhesive and ties. And then you can see here a journey map for the battery replacement that only includes removing 1 screw, which is awesome. Here are our stakeholder packages and our references. Thank you.